5, Section 4, Exponential and Logarithmic Equations. We've had some of these properties already, but as a reminder, our one-to-one properties, a to the x equals a to the y if and only if x and y are the same. The log base a of x equals the log base a of y if and only if x and y are the same. We also have some inverse properties we're going to be using to solve equations. And that says, this one says that if you have a raised to a power that's the log base a of x, well, the a and the power, the log base a, cancel out and just leave you with x because they're inverse functions. Exponentials and logarithms are inverses of each other. And by the same token, log base a of a to the x equals x, because again, the base and the bases cancel each other out and just leave you with the x. Or another way of thinking about it is you're saying a to the x equals a to the x. So we're going to be using these properties and the other properties that we learned, the product rule and the quotient rule and all those things, to solve for equations. And so here's some strategies for that. One is rewrite the equation to fit one of those one-to-one properties. And we've actually done a little bit of that already with our exponential functions. Another tip is in an exponential, isolate the term that has the x in the exponent and then take the logarithm of both sides. And you'll see there's different instances where you want to do that. For example, rewriting the equation is great if you've got two exponentials equal to each other, you know, a number to a power and another equals another number to a power. That's going to work great. And one where you just have a number, just have an exponential on one side, then you're going to want to take the logarithm. In a logarithm, you want to compress it to form one logarithm on one side, if possible, and then rewrite it as an exponential form. And it can look kind of like this. I'm going to show you how to do this using the substitution method. You may not actually need to substitute. If you can, in your mind, treat e to the x, like that whole thing is just an x, then e to the 2x becomes x squared, and you can just kind of factor it without making any changes. But we're going to talk about how to do this using substitution. And what you're going to do is you're going to substitute the letter u for e to the x. So if u is e to the x, then e to the 2x must be u squared. So what we do is we just replace e to the 2x with u squared and e to the x with u. And now we just have a basic quadratic function, which we will factor and set each part equal to 0 and solve for u. But the problem is, we get 2 and we get 1, but the problem is that we want to know what x is, not what u is. So now we have to resubstitute. So we're going to go back and replace u with e to the x. And then we solve both sides of these by taking the natural log. So x is the natural log of 2 and the natural log of 1. And by the way, x equals natural log of 1 means x is 0. And then the natural log of 2 you can put in your calculator to find that value. Now, extraneous solutions can occur when you're solving logarithmic equations. Most commonly, but not always, when we end up with more than one solution. The main thing to remember is that the argument, which is the part after the base, it's usually in parentheses, has to be greater than 0. So if your solution makes the argument negative or 0, it's not valid and you need to exclude it from your list of solutions. All right, so we're going to determine whether each x value is a solution or approximate solution of the equation. And for this first one, all you're going to do is replace one at a time the x with these numbers and see if it works. And say yes or no. And then the last two, the logarithms, you're going to solve. So pause the recording, give this a try, resume to see how you did. Okay, so the first one does work. We get 1021 plus 3 is 1024. 2 to the 10th is actually 1024. Obviously 17 doesn't work, and we really wouldn't expect it to because it's a 1 to 1, so we should have a unique value here. If 1021 works, it really should be the only x that works, and we see the other two don't. All right, in solving for the natural log, the first one, all you're going to want to do is add the natural log of 2 to both sides, and then very simply, x must be 2. In our second one, the easiest thing to do is to rewrite this as an exponential. So 4, you could write 4 to the third equals x. What they did was they took both sides and they made it powers of 4. Another valid way of doing it, on the left, the log base 4 and the 4 cancel and leave you with x, and you have 4 to the third. Either way, you get 64. Pause the recording, give them a try, and resume to check your answer. On this one, all you had to do is set the powers equal to each other. You get a quadratic, which we then factor and solve. For our second one, there's not a number that you can raise to 2 to get 565, so you can't treat this where you get them both in the same base. So what we'll do is we'll take the log of both sides, the natural log, and then what we do is we use the power rule. So natural log of 2 to the 3 minus x, the 3 minus x comes down front, and we have 3 minus x times the natural log of 2, and then we distribute. And then we just work at getting x by itself. So we will subtract 3 times the natural log of 2 from both sides, and then we will divide by the natural log of 2. And notice we also changed all the signs because of the negative out in front. So we get 3 natural log of 2 minus the natural log of 565 over the natural log of 2. And you could actually even just put that in and get negative 6.142 on your calculator. On the final one, you want to isolate the 2 times 2 to the 3x minus 1. So we're going to add the 7 and then divide by 6. And that gives us 8/3. And then what we did was they took log base 2 of both sides. Now, you could do the natural log, you could do the common log. Here they're doing the log base 2 because that just automatically cancels. And by the way, you could have done that also with the previous one. Instead of doing the natural log, you can use the log base 2. If you have the log base, that makes it easier. And so then what we do is that cancels, and we have 3x minus 1 equals log base 2 of 8/3. And we divide that. Well, notice what they did. For some reason, they went and converted it there to common log, which you can do or not. It's up to you. Then you're going to add the 1 and multiply both sides by 1/3 and get 0.805. Okay, try these two problems. Pause the recording while you do them and resume to check your answer. Okay, here this was done without the u substitution. You're certainly welcome to do a u substitution. U would replace e to the x. U squared would replace e to the 2x. Your factoring with u would be u plus 1 times u minus 5 equals 0, which would give you u equals -1 or u equals 5, and then you'd replace those with e to the x. There is no solution to e to the x equals -1 because you can't raise a positive number to any power and get a negative. E to the x equals 5, we're going to take the natural log of both sides to cancel the e, and that gives us 1.609. For our second problem, we are going to take the natural log of both sides, and the reason for that is that argument is just really too complicated to be made into a simple base, so we'll just go ahead and do the natural log. And then what we're going to do is pull the power down front, and we have 365t times the natural log of that mess there, and just divide both sides by everything but t, and put it in your calculator, and you get 21.330. Recording, give it a try and resume to check your answer. So what we did here was you rewrite it. Natural log is base e, so e to the 2.1 equals 6x. Divide both sides by 6 and then put it in your calculator. The next problem, the natural log on the right can be combined using division. So we're going to write it as the natural log of x minus 1 over x plus 1. And so then we have x plus 5 equals x minus 1 over x plus 1. Multiply both sides by x plus 1, and then you're going to have to FOIL that out, get everything on one side and 0 on the other, and solve. And we get -2 and -3. Both of these are extraneous, and if you're wondering why, take them and put them into the original equation. Now, the left-hand side is fine, but that natural log of x minus 1, both of these give us a negative argument. We cannot have a negative argument, so there is no solution to this problem. And the one on the last problem here, what we're going to want to do is to combine the two logs using division. And then they've got, now they did the power on both sides. Another way you could do this easily is 4 to the 1/2 equals x over x minus 1. You just skip straight down to that fourth line there. You're going to multiply both sides by x minus 1 and take the square root of 4, which is 2, and distribute and solve. Okay, for these they want you to use a graphing calculator. So what you're going to do is for y1, you're going to put in the part of the equation on the left. You're going to put in the part of the equation on the right for y2, and then you're going to do the intersect function and see where they meet on your graph. Pause the recording, give this a try, and resume to check your answer. And like I said, again, you're just going to see where the two sides intersect, and here it's at -0.478. And for the second graph, x equals 1.482.